Hello बच्चों, welcome to my channel Physics by HMC and today we are going to start IIT JEE Main PYQ series and I'm starting with the electrostats. Okay, it's a very important topic as point of view. If we see the exam point of view, you will find it, and there are lot of questions comes in every year. You can check it, and in this topic we will segregate the different part. I'm just starting with a very small topic right now, and we will make a series continuously. I will try to put every day some questions, okay, and I will try to make the video little small so that it would be more comfortable for you to watch it and understand the whole concept in that. And in this series I will try to one thing, I will solve the PYQ problem also, and I will try to put all the concept, nearby concept, and which is useful maybe asked and different point of time in the exam and different question. So I will complete that thing, so it will be helpful you to solve PYQ as well as to understand the concept completely. So hope it you will enjoy it, you will learn it from this series. Okay, so we are going to start a very small topic, and it's a very important. You will find that there's 6-7 type of different problems comes in paper. Based on this, I'm telling you the Pith Ball problem. So very first problem, I'm just telling you, this is a problem in a 2021 JEE Main question came. The two identical tennis ball each of mass m and charge q are suspended from a fixed point by thread of length L. What is the equilibrium separation when the each thread makes a small angle theta with the vertical? This is a very basic question. Now we are going to start, and we will learn from this question and other questions also similar kind. Okay, now please understand, we have to draw the diagram. When I'm going to draw the diagram, you will understand here. Just give me 1 minute. I'm just drawing it again. You will see here, this is a diagram. We can draw like this, and here the two these are two pith balls we are hanging in this manner. These are hanging, and this masses given to you, these masses are m. Okay, this mass m, and charges also q. Their charges q, and okay, and separation between them is not given. We are taking it, suppose small r, that we have to calculate also. This length is L, this angle is L, this angle is theta and theta. Now try to understand what are the concept behind it. Very simple thing, put the forces. What are the forces acting? This is a tension. What is vertically downward, that force would be mg, and there would be one force repulsive, because equal and opposite equal charges are there and same nature of charges, they repel each other, so that force would be electrostatic force. That's the very important relation that you have to understand. With the equilibrium condition, that means you can draw, this is F force, downward is mg, that we can say Fe, and this is a tension bacha. Okay, now you can take components, and you can draw again. This is the angle theta with the vertical, this would be t cos theta bacha, and this would be t sin theta. When you are writing these forces, now just balance, because in equilibrium condition forces should balance. You can say t sin theta is equal to Fe, and t cos theta is equal to mg. Okay, just divide these equations. When you divide it, you will find is that tan theta is equal to Fe by mg. My suggestion to you, just remember this result. This is very useful in different questions we will see today. Okay, so this is a very simple thing. Tan theta is equal to Fe by mg, we can utilize. Now question is that tan theta already we can calculate from triangle also. If you see here triangle, so because this distance here is r by 2, and this angle is theta, and length is approximately L, because this is also approximately L because theta is very small. So tan theta, when we are writing it, that would be approximately R by 2 upon L. This approximation is very important. If theta is small, then only we can write, otherwise we cannot write very small. Okay, so try to understand that tan theta is equal to R by 2 upon L, or we can say R upon 2L beta. Okay, this is tan theta. Now using this tan theta and Fe we already know and Mg we know, we put it, you will write here tan theta is equal to, sir, R by 2L is equal to Fe means 1 by 4 pi epsilon naught into Q square, separation is R square, divided by Mg, or we can write more properly that the Q square upon 4 pi epsilon naught, okay, R square into Mg, and left hand side is 2, this q from 2, this is a 2, it will be cancelled. Now you can write very simple line, that would be rq, this r square and this r is there, it will go one side, rq is equal to beta, you can say q square divided by 2 pi epsilon naught into L would be here and this would be mg. This is a very final answer. If you want to remove this q part, so you can say r would be to the power 1 by 3. This whole value divided by 1 by 3. This is a very simple result that you can find it, and you can check the option also. Here the correct answer would be this one. The second would be the correct answer. But from this result, that is the result, if you understand how I calculated, good. But you have to understand one thing, that tan theta is equal to Fe by mg. That's a very important thing. Now we calculated, sometime in the paper they can ask you what is the tension in the same question. Suppose this question comes to you, what is tension? If they ask that thing, to how to calculate, I'm just taking you in the next part, you will understand. So just wait a minute. We can draw here beta, you can say here, this was the picture, we are writing it. This is a picture here, and I'm saying these are two pith balls. This mass is m, charge is q, this mass m, charge q beta. This angle is theta, again this is theta, and this length is L. I want to ask you ki what will be the tension. So you will say here again ki, sir, tension can be written, this is a T, this force was mg, and this is a our Fe. So tension is balancing the resultant of these two forces. So you can say tension is equal to under root of Fe square plus mg square. That we can calculate. Very simple. That's the answer. So this question also can be asked. Now I'm telling you one more concept here. Please understand. Suppose they ask this question, take this whole system, and inside a artificial satellite. Okay, inside a artificial satellite. So if you say this is an artificial satellite, means there would be g effective is equal to 0 beta. There would be g effective is equal to 0. If g effective is equal to 0, or we can say in a gravity free space you take it, then also g effective would be 0. So gravity free space, so gravity free space is there also our g effective is 0. So only two forces acting, that means this picture, if I want to draw it again, you can see this picture would be like this. This is one side and this is another side. So here the point of hanging, and this length is L, it is also L, and these are two pith balls, mass m charge q, this is also mass m charge q. So here, what are the forces acting? There would be tension, it is also tension beta, and opposite direction, that would be Fe, and here also Fe. So here directly you can say, sir, Fe would be very first thing 1 by 4 pi epsilon naught into q square divided by 2L whole square. We can do it. This is the Fe, and this Fe also equal to the tension. So this question can also be asked. You can solve it. It's a very common question related to this Pith Ball problem. We can see some more problem related to this also. Okay, let's come to next problem. This is the again Pith Ball problem. Two identical charge spheres suspended from a common point by two massless string length L initially at a distance of D, and D is much less than L. This is a similar question that we have drawn. So I'm just drawing the diagram, you will understand. Okay, this angle again theta we can take it, and this separation is some distance D, and D is much less than L. It is given to you, D is much less than L. Okay, now try to understand what is given to you. The charge begin to leak from both spheres at a constant rate. If charge is leaking, that means charge is not constant, it is a decreasing. By the way, I'm telling you, this is not only NEET question, this is for Erudov question also. It is originally Erudov question that is copied in the NEET exam. So please understand, respect this question. Very good question it is. Okay, so mass and charge q, mass and charge q is there, and this length is L. So here charge will leak, then definitely their force of repulsion going to decrease with the time. So this balls will come closer. That means theta is decreasing. Theta is decreasing means d distance also going to decrease. So at some point of time I'm drawing it. So this distance would not be now d. This would be some value x. I'm saying this is separation. By the way, this x is also much less than d, L. That is no need to tell. This is also same thing. Okay, this is opening this part. Now question is very simple. I'm asking you, can we write directly tan theta is equal to what, beta? Fe by mg. The answer is correct. Yes, we can write it because just now we have calculated this part. So tan theta means from this equation, if you say, you can say this is x by 2 L, and that value will be, because here to here distance is x by 2 beta, and this perpendicular distance also approximately L. Okay, so this would be x equal to x by 2L is equal to L, tan theta you can write it, and this value is Fe by mg. Fe would be what? Again you can say, sir, this would be k q square divided by x square upon mg. We can write like this. So I'm just rearranging the term. X by 2L is equal to k q square by mg into x square. So this become from here q is equal to mg by 2kl. Okay, and this would be x to the power 3 by 2, x to the power 3 by 2. This is a very simple thing. If I can write it, you can understand this part. So we know the q value from here. So if we know q, this part bracket part is a constant, so you will see the x to the power 3 by 2 is there. I'm differentiating it. So if you differentiate, so you will say dq by dt. That means rate of flow of charge. The rate of flow of charge is flowing. Okay, so this is given to you. You can differentiate this equation. So if you differentiate, you will get this is same thing, mg divided by 2kl to the power half, and this would be 3 by 2 and x to the power 1 by 2. Okay, so this complete part is again as a one constant. I can write some constant k or some a, we will say, and this rate of flow of charge is also constant. I'm writing this rate of flow of charge is r. So you can say, sir, this r is equal to some constant a is equal to x to the power 1 by 2, and this is dx by dt, because when you differentiate x with respect to time, so you will get dx by dt. That is nothing else, velocity. So you can say velocity is equal to this r upon a to the power x to the power 1 by 2, or we can say directly proportional to x to the power minus 1 by 2. So this is the final result of this problem. So when the charge is leaking, that means we can get the answer from this question also. That is a very simple, the x to the power minus 1 by 2. So velocity, that means when they are approaching towards each other, the velocity of the pith balls would be x to the power minus 1 by 2. It's a very simple question. You can understand it. Let's see some more problem related to pith balls. This is the one question, again neat question, again I'm saying it, respected is also earlier came in different exams and very good question, please understand it. The two pith balls carrying equal charges suspended from a common point by the string of equal length. The equilibrium separation between them is r. Okay. Now they are rigidly clamped at the half the height. Okay. The equilibrium separation between the balls now become. Again, the very basic thing. This distance is r given to you. This is r prime, and this distance is y, and this is y by 2. You have to understand it. So now we are going to solve it. So again, you will say in first case also this angle was something theta. This angle is theta. So you can say sir tan theta is equal to r by 2 into y. That is equal to, you can say, k q square upon r square divided by mg. Or you can say sir this become r by 2y is equal to k q square divided by mg into r square. That means r cube divided by y 2y, you can say, and this is k q square divided by mg. This is very simple result of first equation. That means first diagram. Second time this diagram, if you write it, so you can write next. Okay, so when you're writing second for second diagram, so that value would be in this manner, a tan theta prime, because definitely theta is going to change, this angle is going to changes, this is theta prime, this angle also theta prime. So tan theta prime would be r prime divide by 2 upon y by 2 approximately, and that value is equal to k q square upon r prime square upon mg. 2 to cancel this left hand side, this become r prime by y is equal to k q square divided by mg into r prime square. So this become r prime q upon y is equal to kq square upon mg. It is the second equation. So now you know the both equations, just divide it directly. You will say the equation 1 divided by equation 2, that become rq upon 2y upon, you will get r prime q upon 2, sorry not 2, this is y. Okay, and this values, if right hand side you will see this is the kq square upon mg, it is also kq square upon mg, that is going to 1. So right hand side is 1. Okay, so y also cancelled out from here, so you can say sir r prime q is equal to r q divided by 2, or r prime is equal to r upon 2 to the power 1 by 3. That is the final answer for this problem. Again the Pith Ball problem. So you have to understand that this is a one important topic. Try to understand that I am saying to you. Similarly, we will learn some more problems. Try to understand. It's the one question. It's the already JEE advanced questions is there. Okay, and this question is also very fantastic question. It will give you the idea of pith balls as well as buoyancy as well as dielectric. What has happened there? Okay, I'm just telling you a few things. First thing, if there's a buoyancy part is there, so okay, so in buoyancy, first learn it. Okay, suppose one mass is there and it is a hanging. Okay, it's the heavy mass definitely. Then heavy density is more. Density of solid, I'm saying suppose rho s. Okay, I'm saying this is rho s, and density of liquid is rho l. Then remember here we can write it mg minus buoyant force, that is the net force upward, that I'm saying tension here, or you can say net force F net, or sometimes we call mg effective also. Try to understand this line. So we can say mg, and this buoyant force is nothing else, that would be density of liquid into volume into g, that I'm saying mg effective bacha. Now you can say so this is mg minus density of liquid, this is mass upon density of solid into g, that we can say m into g factor. So this is one concept. So from here mg is taken common, this would be 1 minus density of liquid divided by density of solid. So this is the very simple thing that you have to understand it. We can write it. So whenever we require in a Bayes force directly, this concept we can utilize in our questions. Okay, directly we can use this concept. Okay, it will going to help you. Now mg factor we can write it. Second thing is, if a dielectric is there, suppose there are 2 point charges, I am giving you idea. Suppose these are 2 point charges beta, and they are placed at a separation. There is some separation between them is, suppose r, I am saying it, and these charges are given to you q1 q2. Okay, and this is free space. If this is free space, so if free space is there, then the force between them would be 1 by 4 pi epsilon q1 q2 by r square. Okay, this is a very basic thing that you have to understand. Okay, this is a very basic thing. This is a force, but in free space we are writing. If this is not free space, if I'm saying ki these are 2 point charges q1 and q2, and if separation between them is still as a r, I'm saying still r, and now I want to calculate what will be the force if this is a filled with the one medium, and that medium dielectric constant is k. Dielectric constant is k. Remember, this medium is infinitely large, then only we are writing. If it is not infinitely large, definitely we are, that would be result would be more difficult. So if it medium is infinitely large and separation between same, then the force acting between them is 1 by 4 pi epsilon into k. This extra term is coming, that the q1 q2 by r square. Or we can say this f prime, because earlier force we are saying free space f. So this f prime is nothing as f by k. That means force decreases by k times. These two concepts directly you have to remember it. It is going to help for this question. Okay, now I am taking to you next page to solve this actual question what is given to you. Okay, so just wait a minute. I'm just doing the copy of this problem. Okay, now try to see. I'm just removing this all part, we already know. So from this part we can remove it. Okay, we need a one result, and here also we need a one result only. So these two results we need it. So I'm directly writing here is the mg effective is equal to mg bracket 1 minus density of liquid by density of solid. I can use it, and f prime would be f by k. Okay, that we have to understand. So these are two results that we have learned it from previous calculation. Okay, now read the question. What is given to you? Question is this: two identical charged pith balls suspended from a same point, two massless identical thread. Density of each ball is rho, and system is immersed in a density medium of density sigma. The balls remain undeflected. Dielectric constant of the medium they ask. Okay, so undeflected means initial tan theta is equal to final tan theta, means the theta is not going to change. So I'm drawing the diagram, it would be more clear to you better. Suppose this was the picture initially. If we are drawing it, this was the picture. If I'm saying this was the mass m charge q, this was also mass m charge q. This angle is theta, this is theta, this length is l, this is also l. So I can directly say in first case tan theta is equal to fe by mg, because it's the free space right now, so there's no issue, we can write like directly this thing. In second case, I am taking it as a case 1. Okay, second case I am drawing it, and you can understand same picture is there, and I'm drawing it again here. And now this whole part is placed inside a one beaker, and this beaker means one medium is there, and here the medium, this is the medium is there, and its density given to you beta. This density of liquid, and then, or we can say that is equal to sigma, and density of solid is given to you rho. This is given to you. Now we have to solve it. So again you will say that the theta is not changing, that means still in case 2 also this tan theta is equal to fe by mg should be maintained. Yes, So you can say that tan theta is equal to F prime, because medium is there, so dielectric constant would be K, and upon mg effective that we have already written. So F prime would be F by K, and this would be mg bracket 1 minus density of liquid means sigma upon rho. This is the picture that you have to learn it. Now just first equation and second equation has to be equal. Just we will equate it. So equation 1 is equal to equation 2. So this is Fe by mg, and that is equal to Fe means same, that is the K into mg, that is bracket 1 minus sigma by rho. So Fmg is cancelled from here. What is the K value? K is equal to 1 upon 1 minus sigma by rho. This is the final answer, or you can say the rho divided by rho minus sigma. That's the answer for this problem. So hope you are understanding what I'm saying. Okay, this is related to the pith balls problem. You can try some more problem and you can understand it. Okay, thank you for today's video.